Hey guys, today we're going to work on inequalities. Inequalities are math sentences that compare two expressions. Before we were doing equations. When we did equations, we always had an equal sign. We'd have 3x equals 5, or x plus 15 equals 20. That's what we did earlier. Now we're doing inequalities. So we will see these symbols. This is greater than, which means bigger, more than. Okay? For instance, 5 is greater than 3. 5 is more than 3. We can have this, greater than or equal to. Okay? This symbol is for equal, so we've got greater than or equal to. 5 is greater than or equal to 5. 7 is greater than or equal to 5. We're going to have this symbol, less than, fewer than, smaller than. Okay, but think about less than. 5 is less than 10. We will also have less than or equal to. So 5 is less than or equal to 5. 5 is less than or equal to 6. Okay, we're going to take the sentence and change it to a inequality. A number D, this is D, minus, subtract, 2, is more than. So we're using this one, is greater than, bigger than, more than. This is my inequality. Product means to multiply. The product of these two, a number and 7. So we're going to take 7, multiply it by the number x, is at most, the highest, biggest, largest it can be is 25. So it has to be less than 25. It'll be less than or equal to. A solution of an inequality is a number, that makes the inequality true. An inequality may have more than one answer. May have more than one number that makes it true. One solution. Okay? So all the solutions is called a solution set. It's all of the numbers that make the inequality true. Okay? So if we want to know, does negative 6 make this inequality true? When I replace the negative 6 for x, does it make it true? Let's rewrite this. Okay? Remember, when the negative 5 is directly next to the x, the operation between them is multiply. So I'm going to take the negative 6 and I'm going to replace it for x, so it's going to go right over the x. X is gone, there's a negative 6 there. I'll rewrite that, negative 5 times negative 6 plus 1, positive 30 plus 1, 31. Is that greater than 32? Is it? I'm just going to finish writing this out. So is 31 greater than 32? Nope. So that means negative 6 is not a solution. Okay? Oh, no. I hope you guys saw that. Heck on it. Okay. Here's all the work, though. So I took that negative 5 times negative 6. Okay, that gave me negative 5 times negative 6 is positive 30. 30 plus 1 is 31. There is 31 greater than 32. This is not true. Not true. Which means negative 6 is not a solution. Okay, the graph of an inequality. So this is when I place all the solution set on a number line. This is a number line. Okay. Okay, number line. Now, if I graph on that number line all of the solutions to the inequality, that's a graph of the inequality. So if I want to graph x is less than 2, here's my number line. Okay, when it's less than 2, it's an open circle, and I'm pointing to the left. This is less than. I want all the numbers that are smaller than. This is small. This side's big. I want all the numbers smaller than negative 2. And I'm not including negative 2. It's all the numbers less than 2. This open circle means get as close as you can, but it does not include it. If I say graph x is less than or equal to negative 2, now it's a closed circle. I'm going to close that, and I'm still going to the left, less, left. It points to the left, right? It's pointing this way. Okay, that's my solution. If I say x is greater than negative 1.5, negative 1.5 is midway between negative 1 and negative 2. This would be negative 1.5. Greater than, I'm pointing this way. I want all the numbers larger than negative 5. Again, it's an open circle, negative 1.5. Okay, going to the right. If I say all the numbers greater than or equal to negative 1.5, again, it's between negative 1, negative 2. It's going to be a closed circle. And then, again, going to the right. All the numbers larger, greater than, more than, or equal to negative 1.5. Okay? So an open circle, when it's this or this, greater than or less than, it's a closed circle. Greater than or less than without the equal to is an open circle. Okay, I've got examples for you. I've done most of them. I want you guys to try them, see what you can do. And then if you need more help, we'll do it. Okay, the only one, these I think are hard, how they're written. This says, in exercise 6 to 11, tell whether the value is a solution to the inequality. They're asking where the semicolon is this a solution to the inequality? So you're going to take that 2 and replace the u with the 2. We're substituting in. Okay, so 2 plus 7 is 9 less than 4. No, not a solution. Okay, So that's what the semicolon is. It's saying, is this a solution to the inequality? So that one's written kind of weird. The one that is hard, let's go back. Let's see. Okay, I want to do, okay, number 15. Okay, this one you are told to graph it. Number 15, I did not do an example, so I'm going to do here. Every time we've done the variable has been on the left side. So you always want the variable on the left. So I'm going to rewrite this. The t will be here, -3 on the right. Because I'm flipping this, I also have to flip the sign. Notice the open side is to the t, the point is to the -3. When I flip the sign, it has to be the same. The open side is to the t, the pointed side is to the -3. These are both the same. Okay, they mean the same. They have the same meaning. I'm saying -3 is less than t. Here I'm saying t is greater than -3. They have the same meaning. And the reason that I want to do that is so that when I graph it, it makes sense. And I'm going to require you to do this. This is an open circle. I'm going to the right. Okay? You guys try that, see what you can do. Thanks.